We will discuss physics chapter number 2, that is vectors and equilibrium. So let's start with vector. So to define vector, first we will define scalar and then we will define vector. So we have all those qualities present like length, time, acceleration, voltage, velocity and all other qualities that are defined in physics. So all those qualities present in the physics can be divided into two types, either it may be scalar or it may be vector. So which one is scalar and which one is vector? So scalar are those quantities which have magnitude and unit. On the other hand, vector are those quantity which have magnitude, unit, but in as well as direction. To define scalar quantity, we only need magnitude and unit, like 10 kg. In this case, 10 shows the magnitude while kilogram shows the unit. So if you can say that give me 10 kilogram of sugar, so it is done. This is you define the quality. Now in this case, if we say that the body is moving with 10 meter per second towards north, so this is 10 is the magnitude, meter per second is the unit, and towards north is the direction. So to define the scalar we need magnitude and unit, and to define the vector we need magnitude, unit as well as direction. Or the other way to remember this is the scalar quantities are non-questionable and the vector quantities are questionable. How? If you say someone to give me 10 kilogram rice, 10 kilogram rice, here 10 is magnitude, kilogram is unit, and rice is substance or material. If someone says shopkeeper give me 10 kilogram rice, so this is non-questionable. He will directly give you 10 kilogram rice. But if you say someone that Ali went with 10 meter per second, then he will ask, then question will arise. He was told where? He can ask that where the Ali gone. He went towards north, east, west or south. So the question arises in this case. Only magnitude and direction are not enough to describe the quality. You must say the direction as well as. So if you say that Ali went with 10 meter per second towards north, so that is enough. So for scalar quantity, this is not questionable if you say magnitude and unit to someone. But in scalar quantity, magnitude and unit you will say as well as direction to that. The next step is representation. So the easy way to represent vector is, there are many ways. First, you can represent the vectors by arrow on above it, or you can also write letter for that and write or draw arrow below that. So you can draw arrow above or capital letter, you can also use small letter. This is the way of representation. The next is, you can also represent the vector by line drawing an arrow. The length of the arrow will show us the magnitude, while the direction of an arrow will show us and its direction will show us the direction. Now we can represent this, or the third way is to represent vector. You must write the vector as bold. Now to represent whole vector, this is vector. Now as vector, it is made of magnitude plus unit plus direction. So to write its magnitude, we will write it in this way. Also we will write A with a cap. So this is the magnitude with unit, and this will show us the direction. Letter with cap shows the direction. Now you can write the equation power vector is R per direction. You can write or simply for magnitude we can also write as it A magnitude is equal to A vector divided by A cap or A direction. So we can also write this or this. These are three representation of vector. So vector can be represented by this way, either this way, either to write it bold. Now Cartesian coordinate system or rectangular coordinate system. To draw a graph, we use rectangular coordinate system in which we draw line x and y. For 2D, or we use another axis, that is z bar 3D. So we will draw for vector, we will draw an arrow. The angle here shows us direction. If it is 90, then north, east, west, south, or in the length of the vector will show us the magnitude. Next, if an arrow is in 2D, we only need, this is one angle with x axis and this is theta2 with y axis, or we can cause this angle is alpha and the second angle is beta. To know the vector, we only need one angle. For direction, we only need one angle, that is alpha or beta, but only one is enough. But for a vectors in 3D, there are three angles. The one is alpha, beta, and the third is gamma. So in 3D, we need alpha, beta as well as gamma to know the correct position of the vector, because if we know only the alpha and beta, then gamma can move in this direction. So we must also know the gamma to know the correct position of the vector. So this is the point that for 2D we only need angle 1, that is alpha or beta, and 3D we need the angle alpha, beta and gamma, all of these. So must remember that in 2D we need only alpha or beta. In this case we need all angles. The next is addition of vectors. If we have two vectors, how can we add it? So there are two methods. The one is called graphical method, and the second is called analytical. As the name shows, in this method we will use graph or diagram. In analytical method we will use calculation. In graphical method, we will select a suitable scale for representation of given vector. So if we have a vector, the first step is the scale. In scale, if a body moves 100 km, so we can, how much line we will draw. So we will first made a scale, and that we will say that suppose if 1 centimeter is equal to 50 meter, then 2 centimeter is equal to 100 meter. So in that case we will draw a line of 2 centimeter per 100 meter. So this is scale. If a body moves 100 kilometer towards east, 100 meter towards east, then to draw the vector we need 100 meter page. So we normally we don't have 100-meter page. So for that easiness, the first step was to scale. So instead of drawing 100-meter line, we will draw 2 centimeter line that will show us that this is 100-meter distance. The second step is draw vectors. So we will draw all the vector. If this is vector A, this is vector B, and this is vector C. We will draw all the vectors. And next step, we will join all the vectors head to tail rule. Head to tail rule mean first we will draw the first vector, then we will add the second vector tail to S. So the second vector is this direction, and the third will be, and so on. And at the last, we will draw the tail of the first to the head of the last. This is the resultant. Now this is the resultant. Now to find the magnitude of R, magnitude, we will measure its length 1, 2, 3. Suppose it is 3 centimeter. So from the given calculation, we know that 1 centimeter was 50 centimeter. So 3 centimeter is 150 meter. So the resultant is 150 meter. In this way, we find the resultant from graph. The second, to determine the direction, measure the angle with x-axis in anti-clockwise direction. So this is x-axis, this is y. We will measure this angle theta with this, and we will find its direction. So in this graphical method, we don't need any calculation, just we have to draw it on the graph. But the problem is everybody make a mistake here in the calculation, because 1 centimeter shows 50 meter, in some case it may show 500 meters. So if there is a little mistake in this, so we will get the large amount of mistake in, or we will get greater mistake in our result. The next way, that is analytical way, which is based on calculation method. In this case, if we have two vectors, vector A and vector B. Suppose this is vector A and this is vector B. So the first step in this case is we will draw both the vectors. This is vector A and this is vector B, and we will join these with the head to tail rule. Now the next step is we will draw, I would like to give some angle to the B, so we can understand, you can understand it easily. The next is, this is B. So drawing A and B. So first join vector A and vector B with head to tail rule. Now to find the resultant, join with by the head to tail rule. So this is the resultant. Now the first step was draw AB, also join it by head to tail rule. The next step is draw from A on x-axis, so we can get it x-axis of A, and also draw from B on x-axis, we will get bx. So this bx is equal to this part, so we can write bx as here. The next is draw vertical axis the A part, so we will get ay, and also draw by on this axis. So we can say that the resultant this is the resultant rx, which is ax plus by, and this is the resultant ry, which is equal to ay plus by. So in this way we will draw the vectors. Just we will draw its x and y component, and we will, the summation of x component will give us rx, resultant of r x component, and the summation of y will give us ry. Now to find the magnitude of r, as we know the rx and ry, so the magnitude of r will be is equal to, this is the magnitude of r will be is equal to rx square plus ri square whole under the root. To find the direction, we know that tangent theta through proper brushing, perpendicular divided by base, ry divided by rx. We will find it here from here, where theta is equal to tangent inverse ry is equal to rx. So this is the direction and this was the magnitude. So this was the addition of vectors. So in addition of vector we use two methods. The one is graphical and the other is analytical. In analytical there is no calculation, just in the first step in scale, and the rest is the we get the result from the graph. In analytical method we use the calculation and use these formulas. So bear in mind, remember these points, also remember this formula. If you have given rx and ry, or if they give us vector a and b, if they give us a and b, so from a point ax and ay, from b point bx and by. In the next step, from a and ax and bx, sum this and it will give rx, and from ay and by, sum this and it will give us ry. Now to find result, we can find it by rx and iy, that is rx square plus ry square whole under the root. So this was the addition of vectors. So the next is subtraction of vectors. Cumulative property of vectors. Now what does cumulative property state? Cumulative property of vectors. Now for cumulative properties of vector, it means that we have vectors a plus b. So a plus b is equal to b plus a. Either you add a with b or b with a, the resultant will be the same. Or we can also say that a plus b plus c are three vectors. If you add them in any way, like abc or acb or bca or any other way, the resultant in all cases will be same. So this is called cumulative property of vector. For example, let me draw three vectors. For example, if we have vectors a, this is the vector a. Need your attention in this case. This is simple but special example. This is vector a, and we have another vector. This is vector b, and the third I will get it in 45 degree. This is the vector c. Now to prove the cumulative property, then first I will add abc, then acb, then bac, then cab, and so on. So to draw, first I will add abc. So if this is a, then I add b with it, and in third case, and with the addition of third, if I draw c, this is abc. Now to draw the result, I can draw the result by, this is our result in case of if we add a, b and c. Now in second way, if I add b, c, a, what the order is? If I first draw b, then I draw c, and then I draw a. So the result is same. If you add abc or bca, the result is, this will give us the same result. Now I can also draw c, a, b. What will be the resultant? This is c, now cba, now this is b, and that is a. This is the way. If we add abc, cab, cba, abc, bca, bac, then in all the result you will get the same result. So this is got cumulative property of vectors. Now subtraction of vectors. There is no way of subtraction of vectors. You can't add, if we have vector a this is vector A. If you want to subtract B from this, so you can subtract directly it from it. What we do, we use a rule for addition rule for it. So we can write A plus B as A plus into minus B, plus into minus minus, so the result will be same as A minus B. So what we do, we just add the negative of B. What is the negative of? Negative of B mean same magnitude of B but opposite in direction. So if this is B, minus B will be, this will be the minus B. So to find A minus B, we will add minus B with A. So what will be, this is A. Now if we add B with it, so this will be B. So this is A plus B result. Now if we want to A minus B in this case, so we will draw the B, but instead of B we will draw minus B. So this is minus B. This is same as B but opposite in direction, so we will call it minus B. Now add A minus B by head to tail rule. This is what we get. This is A minus B. So for subtraction, we add the negative of second vector with A. Next is multiplication of vector. Multiplication of vector. So if we have vector A, which is here in this case. Now if we multiply it by number, suppose 2, so it will give us 2A. If n, then we will get the result as NA. 2A mean vector will be double. So if it is A, if we multiply by 2, so we will get the result is 2A in same direction. If we multiply it by minus 2, then result will be minus 2A. In that case, magnitude as well as direction will be changed. So in that case, we will get the result as this minus 2A, which is made up A in A. So what is the summary? The summary is that if we multiply a vector by number positive number, then its magnitude will change. It is in this case. And if we multiply it by negative number, then magnitude as well as direction will change is in this case. So what we studied in this topic? So first, cumulative property mean that A plus B is equal to B plus A, or addition of vector doesn't depend on order. So this was the point. It came in ETEA 2013. Now the next is subtraction. Though in subtraction we add the negative of vector. So also remember this. Now for multiplication of vectors, if we multiply it by positive number, magnitude change in magnitude will be occur, and if we multiply it by negative number, they will change in magnitude and as well as direction will be observed. So this was the magnitude multiplication and this. And next is resolution of vectors. Let me remind you addition of vectors to define resolution of vectors for that. Now we know that if we have two vectors, if this is vector A and this is vector B, to add these we draw it vector A, then we draw vector B here table, and we join the result. This is the result. So this is called addition of vector. Now what if they give us the resultant? If they give us the resultant and they ask to find us its vector or resolve it into vector, we can say the resultant is made of A and B. Now if they give us this, the resultant, and ask to find its two vectors, so to find the vectors of given vector or to resolve a given vector into its component, this process is called resolution of vector. So in resolution of vector, how we will find its two vector? We will draw a line perpendicular from its top. So first we will draw it on axis. So drawing law from top to bottom on x axis, so this will give us x component, and drawing law on y axis, it will give us the perpendicular component. So this is the way. So this is the rx and this is the ry, and this is the angle theta and all of these. Now to find the x component, Rx or Ry, or if they give us the vector f, now to x component this will give us the x component and this will give us the y component. Now how to find Rx and fx and fy or Rx and Ry? So if this is, we can draw this fy can be represented by this, both are same, so we can write as, so we can draw this diagram as r f, r y and r x, or we can, for f we will draw as f fy and fx. So if we have this triangle in which one angle is 90, so we will find sin theta, cos theta and tangent theta. So we know that sin theta is equal to perpendicular divided by base hypotenuse. This is perpendicular, this is base, this is hypotenuse. So sin theta is equal to perpendicular divided by hypotenuse, cos theta is equal to base divided by hypotenuse, and tangent theta is equal to perpendicular divided by base. Now how to remember this? There is a formula for this, we call it some people have curly black hairs through proper brushing. So this is the formula for how to remember this. We use the formula this. Here how it is used, this is some people have, this is for sin theta, how, this is s which mean sin theta, people means perpendicular, have mean hypotenuse. So some people have, this is numerator, this is denominator, and this is the angle, angle numerator denominator, same angle numerator denominator, angle numerator denominator. So in this case, in second, curly mean cos theta, black mean base, hypotenuse hairs mean hypotenuse. In this case, through proper brushing, tangent theta is through, proper mean perpendicular, and brushing mean base. So this is the formula we use to remember sin theta, cos theta and tangent theta. So here sin theta is equal to perpendicular divided by hypotenuse, fy divided by f, fy divided by f, and cos theta is equal to base divided by hypotenuse, that is fx divided by f. So to find fy is equal to f sin theta and fx is equal to f cos theta. So this way we resolve a given vector into its components. Now if they give us fx and fy, we can find the resultant by Pythagoras theorem, that is f is equal to fx square plus fy square whole under the root. Now to find the direction, we will use here tangent theta is equal to perpendicular divided by base, fy divided by fx, or theta is equal to tangent inverse fy divided by axis. So this was all about resolution of vectors. Now to what was the point? The point was to resolving a component given vector into its two components. It's called resolution of vector. Now we will use the formula sin theta, cos theta, tangent theta. For that, if given vector draw line on x axis, it will give us rx, on y axis it will give us ry. Next, sin theta is equal to fy divided by f, where fy is equal to f sin theta. So must remember it. Fx is equal to f cos theta. And for magnitude of given vector, if they give us fx and fy, we will use this formula, and for direction we will use this formula. In 3D case, what will happen to f? There will another component z, so we will use f is equal to fx square fy square plus fz square all under the root. Now if they have given ry, rx and fy and fx, so according to Cartesian coordinate system, this is Cartesian coordinate system, x minus y minus. If the given, this is the given vector of which both x and y vectors are positive. So if they have given both x and y axes are positive, then it lie in, resultant lie in x first coordinate system, because in first coordinate system if this is given vector, its y and x's are positive. So if the given vectors components are both are positive, it means that it lies in first quadrant. Next, if the y is positive and x is negative, that it lies in second quadrant. For first quadrant, now let me make some space. Now in first quadrant both x and y were positive. In second, y is positive and x is negative. X is negative and y is positive for second. In third quadrant both y and x are negative. If we draw a line, this is y which is negative and x is negative. So in third quadrant both are negative. In fourth quadrant x is positive but y is negative. So this is if they have given from positive and negative sign, we can point it in which quadrant it lies. This was all about resolution of vectors. Example which may come in ETEA. Two vectors each of 20 Newton and this Newton are making an angle upon 20 Newton. Find the r and r that will replace them. The question says that this is the angle A and B that are making 120 degree. So in first, to find r, so this AB are acting, so the resultant will be in this direction in the middle of each other. So this is the resultant r. Now the r that will replace them, it will be same in magnitude but will be the opposite in direction. Though this is minus r, the r that will replace them. So simply we have to find the resultant. Now how to find? This is the vector 1, that is 20 Newton. This is the 10 Newton. To find the r, we will use this formula. This is the formula, but for this we need rx and ry. Now for rx, which is the component ax plus component bx, or ry is the ay plus by. Now if this is vector a and b, we need its x components and bx components to find ax and bx, and for ay and by. Now here we will find ax and ay, and this we will find bx and by. So from ax we know that ax is equal to a cos theta, where a is this b's and cos theta is cos 120. Now b's into cos 120, cos 120 is equal to minus 0.5. Now how I did put in 0.5, I will discuss it in the chapter number 1. In the same way, to find ay, we will use ay is equal to a, that is 20 sin theta, that is sin 120, and sin 120 is equal to minus 0.5. So b's multiply 0.5. In this case, same as for bx, where bx is equal to b cos theta, where b is 10, cos is equal to cos 120, and by is equal to b sin theta, where b is 10 and sin theta is sin 120. So putting values, we will get here values, where this is for f1, as we draw it on x-axis, so far this angle will be 0. So in this case we will put angle r 0 in both cases. So sin 0 is equal to 0, so there at ay component will be 0, and cos 0 is equal to 1, and cos 120 is equal to 0.5 minus 0.5. This is cos sin 0 is equal to 0. If this is 0, and cos 0 is equal to 1, so we will put here 1. So the answer is 120 angle applied. So how where to put cos 20 and sin 20 and what's are at value, other 0.5 0.7 are at, I will discuss it in chapter number 1. You can find it without calculator, or I will write another lecture on this. So now what? Now add ax with bx and ay with by. Ax plus ay will give us rx and ay plus by will give us this, and we will find the r. For direction we will use tangent inverse ry divided by rx. So in this case we need calculator, so this is not important, but they can ask about the magnitude. Now the next is that MCQ that is important for area eta, that if we have two forces each of magnitude f and the resultant have same magnitude, that is f. So if this is triangle, two forces acting on it. So if only three forces if act on, this is the whole degree is 360 degree, and these three forces are equal angles, so the angle between each forces is 120 degree, 120 degree, 120 degree. So it's from 120 degree each force is acting on center of, so they will affect the cancel of each other and the resultant will be 0. So if from three sided equal forces are acting on triangle at x of b degree, it means the resultant is 0. So if we have two forces each of magnitude f and the resultant here also the magnitude of f, so the angle must have be x of b degree. So no need to solve this example, just remember it by heart and do it by this way. Is product of two vectors. So if we multiply two vectors, it will give the result is scalar or the vector. So the scalar, if we multiply two vector and it give a scalar, so we will call it scalar product. If we multiply two vectors and it give us result is vector, so we will call it vector product. Scalar product is also called dot product and vector product is also called cross product. If we have two vectors, then a dot b is equal to ab cos theta. This is the result is scalar. Now a cross b is equal to ab sin theta. In this case, this is vector a and this is vector b. So this is b, so it's b cos theta is this angle. So this is a and this is b, so bx is equal to b cos theta, and b cos theta in same direction, so we will use this b cos theta factor of b. So in a dot b is equal to ab cos theta, a is magnitude a and b cos theta is that vector of b that is parallel to vector a. Now in a cross b is equal to ab sin theta, so this is a and this is b, its components are bx and by. So in this case ab sin theta is, we will use a and b sin theta is that part of b that is perpendicular to b are vertical component of b, that is by. So by is equal to b sin theta. So in this case b cos theta is that vertical x component of b, in this case b sin theta is vertical component of b. So if they say a dot b, so a dot b mean is equal to ab cos theta or abx, and a cross b is equal to ab sin theta or ab y. So in this case we need vertical component, in this case we use x component. Its example is work and this example is dark. Now why a question arises that in scalar product why we use cos theta and why we use sin theta. So the question is, we know that sin 0 is equal to 0 and sin 90 is equal to 1. Sin 90 is equal to 1. This is the maximum value of sin theta. In this case cos 0 is equal to 1. This gives us maximum amount of maximum amount is 1 it cause 0. Now in W, force act on a body and produce motion in its on direction where angle is equal to 0. If W is at angle 0, then the work is maximum. At angle 0, cos 0 is equal to 1. So W is equal to FD cos theta. So at angle 0 of anything, if work is at angle 0, the body gives us maximum value, then we will use cos theta. Now this is torque, this is R, and force in R at and perpendicular. Now if the angle is 90 and the quantity is maximum, like in this case that is torque is maximum at angle 90, so we will put sin 90. So at 0, as we know that cos 0 is equal to 1, maximum value is we can get by cos. So in that case, if W is gained by maximum value is 0, so we will use cos theta. Now if 90 anything, we will get value maximum value at 90 degrees, so we will use sin theta, because it's sin 90 the maximum value we get. Now for component, if we have two components, must remember that area is vector component. This is the area of two component A and B, and you have to find the direction. Make your hand this like, put it on one vector, move it towards another vector, so thumb will give us the direction. So if we move this vector towards this direction, so the thumb will give us the direction, and this, which is the direction of area. So for this whiteboard, the direction of area is either this or inside the board. And for hand, if this is a steady surface, to point its direction, if this is side 1, side 2, so direction upward or downward. So for area, direction is upward or downward, that greatly affect magnetic flux or electric flux. The next topic is torque or movement of force. That is simple, we may have discussed it in many chapter. So we know that when R force applied in R, they produce torque, or torque is equal to R cross Fy. R is equal to R F, R cross F is equal to RF sin theta. What is F sin theta? That are part of B that is perpendicular to F. So if this is R, force act on it, so torque is equal to RF sin theta. In this case, where theta is 90, so sin 0 is equal to 0, sin 90 is equal to 1, so maximum torque will be produced. If R and force are in same direction, so in this case sin 0 is equal to 0, so torque is equal to RF 0, that is 0. So if R and F are in same direction, angle is 0, then torque will be 0. If this is R and force act in opposite direction, it means if angle is 190, so sin 180 is equal to 0. In that case, torque will be again equal to 0. So this was all about torque. The next is equilibrium. That is easy topic in of class 10th. So for a body to be in equilibrium, so there are two states for a body in be equilibrium. Either it is in state of rest. So a body, if it is rest, this duster is lying, so this is at rest. The next is motion. If a body is at continuous motion, we can say that it is in equilibrium. As earth moves around the sun continuously, so we can say that the earth is in equilibrium. To discuss equilibrium, we have the term that is used as concurrent forces. What is concurrent forces? If two or more than two forces acting on the same point, we call the forces as concurrent forces. Now for the equilibrium, there are two conditions. Condition number A, that sum of all forces is equal to 0, and condition number 2, sum of all torque is equal to 0. Sum of all forces is equal to 0 if this is a body, two forces acting on this x-axis and y-axis. It means that sum of all x forces is equal to sum of all y forces, or sum of x forces is equal to 0. This x forces will cancel the effect of each other, and if this y component cancel the effect of each other, so we can say the body is in equilibrium. Or sum of all torque is equal to 0. It means that if clockwise torque is equal to anti-clockwise torque. To understand the equilibrium, for a body is said to be in equilibrium at has 0 acceleration. So if a body is at rest, A is equal to V divided by T. So if at rest velocity is equal to 0, so A is equal to 0 divided by T. So this is in for rest, it is in acceleration is 0. So we can say that the body it is in equilibrium. Next is if a body is moving in straight line with continuous or fixed velocity. If body is moving with 10 meter per second continuously, so we can say that there is no changes occur. As changes occur, it is 10, no changes occur, so 0 divided by T is equal to 0. So again it is in area acceleration is 0, so we can say that it is in translatory equilibrium. Now, sorry, I made here a little mistake. If a body is moving in a circle like Earth, so as its magnitude is same, velocity is same, but each point its directions is different. So the change in direction also cause the change in acceleration. So we can't say if a body is moving in a circle, it is acceleration due to change in direction of velocity. Change in direction of velocity. Velocity is a vector, it is magnitude as well as direction. So as change in direction occurs, so we can say that change in velocity occur, and if change in velocity occur, we can say change in acceleration occur, and if change in acceleration occur, we can say that the body is not in equilibrium, because for equilibrium we have 0 acceleration needed. Our body must have 0 acceleration. Now, how to learn this equilibrium? I will draw an example. But before go to example, I would like to give a touch to the vector component. Now, again, to understand vector, always take force as example of vector, and force simple push or pull. Now the MCQs is the minimum number of forces, the minimum number of equal forces to keep body in equilibrium. Now this was the equilibrium. So simply we say that if this is body, the body A, someone attract it from the pull it from right side, and someone pull it from B side with same force, mean same vector. So if they will cancel the effect of each other, and the body is said to be in equilibrium. This is for equal forces. If two equal forces act on opposite in direction, so we can say that a body is in equilibrium. So for body in equilibrium, minimum number of equal forces are 2. Or you can also say if this is a buoy and someone is pulling it from right side and other one is pulling it from left side. If someone is pulling from right side 10 Newton force, another buoy is pulling it by 10 Newton force also. So the body will move not to x direction and not to y minus x direction. He will be as stated it as its on position. So there are minimum 2 forces if they are equal. So minimum number of equal forces are 2 for a body to be in equilibrium. The next is minimum number of unequal forces for a body to be in equilibrium, for equilibrium. So if this is body, Ali is pulling it with 10 Newton force and Ahmed is pulling it with 10 Newton force. We need unequal forces. So how it will be in equilibrium? For equilibrium, it doesn't change its position. So if we want it doesn't change its position, so we will pull it also with extra 2 Newton force and 10 Newton force, and another third force is must needed for a body to be in equilibrium. So the minimum number of unequal forces are 1, 2, 3 for a body to be in equilibrium. The next is if we have two forces equal magnitude F, and the resultant is also the magnitude of F, what is the angle? So this is the F on triangle, F at x ob angle. These three forces the effect of each other. So if this is the two given forces, the resultant is also F. So in that case the angle is x ob degree. Now and next is when will be the resultant of two forces will be maximum. So if this is again an object, someone wants to move it from this position to A position to B position, and two boys, boy A is x and boy B, want to carry the object from A to B. So they both will apply forces or vector. So to get maximum resultant of these forces or maximum resultant of these forces, they must act or they must apply the forces in parallel to each other. If somebody is pushing something, if they apply the forces in the same direction, then we only in that case we can get the maximum result. So if they push the cotton in same direction, so only then we can get the maximum resultant. So for maximum resultant of forces, the angle is 0 degree. So this was the about vectors. Now for x is y axis or for a state of equilibrium for which sum of torque is equal to 0, I would like to solve MCQs on this. That is from book example, that is MCQs number 8. Find the mass of the rod. Find mass of the rod. हमें मालूम करनी है mass. We have to find mass as shown in figure. Its center of gravity is G is 14 centimeter away from A. So in the diagram they have draw as this is the diagram. Fixed is here. Now this is 30 centimeter. Now from 20 centimeter we have added another mass of mass 80 gram, and next is we have from G at 14 centimeter from, so G is 14 centimeter. Now we have to find the mass. So first of all, the first step is, if this is 14 centimeter, then it must have 16 centimeter because total distance is 30. 40 plus 16 is equal to 30. Now the first is how the body will rotate. So this is the center. So this side will act as in this direction, and this side will act as in this direction. Now taking this is a center, we know that this is clockwise torque and this is anti-clockwise torque. So the body in equilibrium, sum of all torque is equal to 0, or clockwise torque is equal to anti-clockwise torque. So in this case, as most of the weight lies in this direction, so the beam will try to rotate in this direction and the mass will rotate in this direction. Now torque of beam or torque of A, and this is body B, we call it B. So this is anti-clockwise direction. So this is the distance. We will start measuring distance from center, so from pivot or which the body moves. So here this distance is 16 centimeter. Torque is equal to RF. R is equal to 16 multiplied by its, we have to find its mass. So we will put F, or F is equal to mg. And next is clockwise torque is equal to 80 gram mass, and R is 20 centimeter. R cross F or R mg. Here R is 20 and M is 80 gram and G is 9.8 is equal to 60 mg. So G cancel with G, we will get 20 multiplied by 80 is equal to 16 multiplied by mass. This is the mass of beam which is unknown. So we can find the mass from here, where M is equal to 20 multiplied by 80 divided by 16. 16 5s are 80 and 5 into 20 is equal to 100. So 100 gram is the mass of beam. So the option A is correct. So this was the example, little tricky, so I solved it. It's enough for today. No need to solve any example because I discussed all the points. And must remember the minimum number of forces for body in equilibrium, maximum number of equal and unequal forces, and I can write it again. Minimum number of equal forces are 2. If these are unequal, so it may be 3. The number is vectors maximum resultant at 0 degree. The next was if resultant, if two forces have same magnitude, the resultant can be same only at angle of 120 degree. And next was in vector scalar product. Scalar product is also called dot product, and we will use angle cos theta. And vector product we also call cross product, and we will use sin theta. And next was for equilibrium, a body must have 0 acceleration. Now if body is moving in a circle, it is velocity is constant, but change in direction of velocity occur. So is change in velocity direction is occur. So A is equal to V divided by T. As V is changing, so A will change, it will be not 0. So a body moving in a circle with constant velocity is equal to, is not in equilibrium. This was also the main point. The next was torque is equal to RF. So torque is equal to RF sin theta. So sin 0 is equal to 0. So for 0 the torque is 0. For 0 the resultant of torque is 0. Putting 90, sin 90 is equal to 1. So we will get the result as RF, that is the resultant is maximum result. So this was all about the chapter number 2, vectors and equilibrium. It's enough for today. See you in next lecture, next class.